Hey, welcome to the Math 980 discussion for 2.5, which is on absolute value inequalities. Right. So I've had a couple of questions asked about this section, so we'll go through those. Let's start with number 3. Number 3 is one of the basic ones. Nobody actually asked this, but we're doing it just to get the basics covered here. The absolute value of x is greater than or equal to 3, right? So again, if you think about what's happening here, the absolute value of x being greater than 3 means greater than or equal to 3 means that it could be 3 or more. Right? All of those numbers are further away from 0 than 3, or are 3 away. But again, we've got this other side, this negative 3, right? Fill it in, also could be further away on the other side, right? So our answer here, graphically, is this. If you wanted to put it into interval notation, which you'll be required to every once in a while, that would simply be negative infinity up to negative 3. There's a gap here, so that's a union. And then we would go from 3 to infinity. And then, of course, the infinities always get the parentheses. I made a mistake here because I'm talking and chewing bubblegum at the same time. But we should have brackets here, right? Because the 3's are included. And so this is our interval notation. All right, pretty simple one. Let's look at number 4. Four says, just kidding, 4 is basically the same thing. Oh, 4 is the interval notation. All right, my bad. 7, let's look at 7. Seven says we have x plus 3 in the absolute values now, and that is less than 7, right? So it's still the same idea, whatever this number is, but in this case it has to be less than, right? So remember that that's the and statement. It has to be within these bounds. And so this becomes x plus 3, could be less than 7, and it also, x plus 3, has to be greater than negative 7, right? If you think about where that x plus 3 could be, it has to be between negative 7 and 7 in order to be less than 7 away from 0. Right? And then I just solve each of these individually. Minus 3, and if you are a visual person, you're just looking at a graph that is now being shifted by 3 units, right? This x then is less than 5. Minus 3 gives me x is greater than negative 10, right? And it's still an and. So if I want to graph this guy, it's got to be less than 5, so call some point 5. It was a strict less, unless I wrote it wrong, I didn't. Strictly less than 5, strictly greater than negative 10, so it's those numbers in between. There is no union, right? It's an and, so it's simply negative 10 to 5, parentheses on both sides. Okay, good. All right, let's look at another one like that, similar. It's number 9. Nine says we have magnitude, the absolute value of x plus 5, plus 3 is greater than 5. And you'll want to always isolate this absolute value before you do anything, so I want to get this plus 3 out of here. I can do that with the addition principle for free. Minus 3 from both sides leaves me with the absolute value of x plus 5. Greater than still 2. The absolute value being greater than means it's further away, which is an or statement. And so this turns into x plus 5 is greater than 2, or that x plus 5 is less than negative 2. This less than got a little curly on me. There we go. -5 to solve for both of these, that gives me x is greater than -3, or if I -5 on both of these, x is less than -7, right? And so graphically, if it's greater than -3, pick a spot, call it -3, open circle and greater, or it could be less than -7, open and shade it to the left, right? And so we would turn this into an interval notation, I'll leave that to you, but it would be a union because there's that gap. Right? Okay. All right, let's look at number 12. Says -6 minus 4 times the absolute value of 2x minus 3 is greater than 2. Now again, I want to isolate this absolute value. We've seen the big no-no, don't try to interact these two numbers together, right? This is not -6 minus 4 and then do other stuff. The order of operations says this 4 belongs to the inequality, so just get rid of this -6 by adding 6 to both sides. It gets rid of it, leaves the -4 that's being multiplied by the 2x minus 3. That's still greater than, and I have 8, right? Now I still want to isolate the absolute value, so I'm going to divide both sides by -4. That's how I get rid of this -4. I'm dividing an inequality by a negative, so what does that do? That flips this sign, and now it's less than -2, right? And I can stop here. When I've isolated my absolute value in an inequality or an equality, and I have a negative number on the other side, this is either everything or nothing, right? This absolute value will never be less than a negative, and so it's nothing. Nothing's going to work here, right? And we're done. Okay, let's look at 13, which I feel is probably going to be similar, but the opposite case. Thirteen says 12 plus the absolute value of x plus 7 is greater than 5. Okay. So again, I'll try to isolate that absolute value expression, and I'll start by subtracting 12. And actually that isolates it. I have the magnitude of x plus 7 is greater than, since I didn't divide, I don't have to switch anything, but it's greater than -7. And so I stop, and I ask myself, is this everything or is it nothing? And no matter what I put in here, I'm going to take the absolute value of it, so I'll get 0 or more, and that's definitely going to be greater than -7, and I'm done. That is everything. Right? And that's that. Alright, thank you, and I will see you guys for 2.6.